Hello everyone, welcome to this new video series on ADAM programming with R Tidyverse for clinical SAS programmers. In this series, we will see how to implement key ADAM programming concepts using R. In this video, we will see how to derive key date variables which are commonly used in ADSL dataset. Please note that the videos are organized in separate playlists and the links can be found in the description of this video. So let us take a look at the specification first and then we'll see the input data and then we'll see quickly the SAS program and then we will see how that can be replicated in R. So let us open the specification. Here we have derivation logic provided for informed consent date, date of randomization, date of first exposure to treatment, date of last exposure to treatment, and date of first visit and date of last visit. So these are some of the commonly used date variables in ADSL dataset. So let us take a look at the specification or derivation algorithm for RFICDT. So we are being asked to use SDTM DS dataset and then the logic is provided as get RFICDT as the numeric of date part of DSSTDTC on the record where DSCAT is equal to protocol milestone and DSSCAT is equal to informed consent obtained and DST code is equal to subject informed consent. So we are being given the record filter condition and from that record we are being asked to use the value of DSSTDTC and convert it into numeric after extracting the date component. Similarly, for randomization date we are being given the filter condition for the record which has to be used. So here DSCAT is equal to protocol milestone and DSD code is equal to randomized, and from that record we will have to use DSSTDTC and extract the date component and convert it into a numeric and name it as randt. And for SDT, so we are being asked to use exposure dataset and the filter condition is set as EXCAT is equal to treatment period. But here there can be more than one record with the filter condition of EXCAT is equal to treatment period. So we are being asked to use the earliest record of a subject and from that earliest record we are being asked to use the EXSTDTC value, convert it into extract the date component and then convert it into numeric and store the value in TRT-SDT. Similarly for TRT-EDT we are being asked to use the EXENDTC of the latest record where EXCAT is equal to treatment period. So for FVISDT, so we are being asked to use SV dataset and it says get FVISDT as the numeric date part of SVSTDTC of the earliest record for a subject from SV. So for LVSDT, it should be similar, but we should be extracting the latest record of a subject. And it said maximum of SVSTDTC and SVENDTC of a subject. So there can be cases wherein SVENDTC is null, but only SVSTDTC is populated. So in order to fetch the last known visit date, we are being asked to consider these two date variables. So in fact, same thing can be applied for TRT-SDT, TRT-EDT as well. So to consider both the start and end date variables from the same dataset on a record and then we can pool them and then fetch the latest of those two or the earliest of those two based on the variables requirement. Now let us quickly see let us take a quick look at the input datasets and then we'll move on to the SAS programming. So let me zoom in a little for this. So here we have our demographics dataset. Here only essential variables are kept for this lesson. And then we have our disposition dataset which contains the protocol milestone and disposition related information. And then we have our exposure dataset which has records for EXCAT is equal to run-in period and treatment period. And then we have our SV dataset which contains one record per visit per subject with the start and end dates of that visit. So these four datasets will become input for us for this lesson and then we'll be deriving our variables RFICDT, RANDT, TRT-SDT, TRT-EDT, FSDT and LVSDT. So let us now move to the SAS program. Let me zoom out a little. So this should be around 125%. Yeah. So Now we'll quickly examine the SAS program and how this can be derived. So for RFICDT, so we are being we were asked to use DS dataset. So we are using DS dataset and creating a dataset called RFICDT. So we were given a filter condition for the row to be selected. So we are applying that filter and selecting only those rows. From that row, so we were asked to use the DSSTDTC and convert it into numeric after extracting the date component. So we know that if we have the date in ISO 8601 format, when we have both date and time, the first 10 characters are meant for capturing the date value. So we are extracting that date component here using substr function and then converting it into numeric format using input function and then the in format of yymmdd 10 dot and then storing the value in variable called rficdt, and then we are applying a format of date9 for this rficdt and then keeping only the required variables. So in the cases wherein we will have to subset the record, it can be done in a single step. We filter that and then we apply the required transformation on the date variables and store it in a new variable and keep only the required variables. So next, similarly for randomization date, again the requirement was to use DS dataset and filter the records based on the condition provided in the specification and then convert the DSSTDTC on that record to randt variable and keep only the required variables. And then for TRT-SDT, so we were asked to use the records from exposure data and the records corresponding to treatment period based on the value in EXCAT variable. And then we are filtering only those rows where exposure start date is not null. So we know that there can be multiple records in exposure per subject within a EXCAT value. So from that we were asked to use the earliest. So here we are making sure that the records are sorted in ascending manner of EXSTDTC within a subject. So when we sort in ascending manner of exposure start date within a subject, the first record within each subject will have the earliest date. So here we are subsetting the earliest record by making use of if first dot u sub jd after specifying that our records are sorted based on u sub jd and exposure start date. And then we are extracting the date component and then converting it into numeric and storing the value in TRT-SDT variable and keeping only the required variables. And then similarly for exposure end date, we were asked to use the latest date from EXE and ETC, and we were asked to filter the records corresponding to EXCAT is equal to treatment period. And then so we are sorting here the records based on u sub jd and exe and etc. So when we sort in ascending manner, the latest date will be available on the last record within each subject. So we will have to subset the last record within each subject. So we are achieving that using if last dot u sub jd here. And then we are again extracting the date component and then converting it into numeric and assigning it to the required variable, in this case TRT-EDT, and keeping only the required variables. So, and now we are coming to the derivation of date variables from SV dataset. First one is FVSDT. So here we were asked to use the earliest date from SV dataset of SVSTDTC variable. So we are sorting the dataset based on u sub jd and SVSTDTC and then filtering the first record within each subject and then converting the extracting the date component and then converting it into numeric and storing in variable called FSDT and again keeping the required variables. And similarly for EX, E and DTC, LVSDT, so we were asked to consider both SVSTDTC and SVE and DTC when fetching the latest record. So that is here achieved as like if when SVE and DTC is missing, we are assigning the value of start date to the SVE and DTC and then sort the values based on u sub jd and SVE and DTC. So the last record will have the within each subject will have the latest record. So for that we are subsetting the records based on if last dot u sub jd and then using the date value from SVE and DTC and converting it into numeric and storing it in LVSDT variable and then keeping only the required variables. Now we have all the individual variables available, date variables available in separate datasets. We need to fetch them into our demographics dataset. to have all the variables in single place. So we are achieving that using a merge step. So we are using demographics dataset and all the important data sets which have the derived date variables on the right hand side, and then filtering only those subjects who are present in demographics domain. And finally, we created a data set called output and kept only the required variables. So this is how we can make use of SAS to achieve the end result. Now we will see the R programming in detail. So let me open the tidyverse program here on the left hand side of my screen, and the intermediate datasets that are getting created from tidyverse here on the right hand side. So uh, as mentioned in the title of the video itself, we will be majorly using functions from tidyverse package. All the other libraries are noted for this is kind of an auto.exe file for me, so I have included all the libraries. In some places I may use some of the functions from other packages, but majority of the functions are from tidyverse package. So similar to the previous videos on STTM, so my input data, the code to create the input data is present in a file named this way, and I am calling that program within this program, so that all the code from that R program is executed within this R program, and input data sets are available for downstream processing. So as mentioned earlier in the previous videos of SDTM as well, source function is equivalent to our %include statement of SAS. So here we are deriving RFIC DT variable. So we are creating a dataset named RFIC DT by using disposition dataset as input, and then we are feeding the disposition dataset to the filter function. So in the filter function, we are providing the filter condition provided in the specification, which is dscat is equal to protocol milestone, comma dsscat is equal to informed consent obtained, and dsd code is equal to subject informed consent. So if we have to filter condition based on multiple conditions with an and in between, so what we can do is we can separate the individual filter conditions with a comma in between. So for this comma gets translated as and in between these variables. So we are filtering the required records and feeding that into the mutate function. The filtered DS dataset is fed to the mutate function. So mutate function is used for creating new variables or modifying existing variables. So in this mutate function, we are creating a new variable called RFICDT. How are we creating it? We are creating it as date of DSSTDTC. So in all the input datasets, I only had like exposure information, date components only. So we can make use of as date function to convert the dates in ISO 8601 character format to numeric format. So here this is kind of equivalent to our input function with in format of YYMMDD 10 dot, which is the default for date representation for as date. So we are converting the DSSTDTC to numeric and then storing the resulting value in RFICDT variable. So in SAS we have made use of keep is equal to keep statement of data step to keep only the required variables. So we are making use of select function to keep the required variables here in R. So filter for the required records, use mutate function to create new variable. So and within that, in order to convert the date values to numeric, we are making use of as date function, and then using select function to keep only the required variables. So the resulting RFICDT, so we can take a quick look at this and how that looks like. So here if we see, we have record for user ID and the resulting RFICDTC is stored here. So again, this is a numeric notation, though the values are appearing in form date YYMMDD 10 dot format. So in the next step, what we are doing is we are creating a new dataset named RANDT. Again, here we are using disposition dataset as input and then feeding it into the filter function to filter the required records, and then passing it further onto the mutate function to create RANDT variable as by converting DSST DTC to numeric date value using as date function, and then further passing it on to the select function to keep only the required variables of uSubjID and RANDT in this dataset. So if we take a look at RANDT here, so there are of the 3 subjects present in demographics domain, only 2 subjects are randomized. For those 2 subjects, now we have randomization data available in this dataset. So for exposure, so we are creating a new data set called EX01 by combining the data from uh, exposure data twice. The first time we are using exposure and renaming DTC as renaming EXST DTC to DTC, and in the second instance what we are doing is we are appending the rows, but this time in DTC variable we are using the value from EXE and DTC. So this has been done to pick the earliest or latest of exposure dates from both EXST DTC and EXEN DTC. So we have a single data set now which contains a variable called DTC to hold the values from EXST DTC and EXEN DTC as well. Let us take a look at EX first. So here if we see we have 4 records, and if we take a look at EX01, this should have now double the number of records present in EX. So we are expecting 8 records. So here if we see in the DTC variable, for the first instance we are using the value from uh, EXST DTC. So I think EX01, what is happening here? Yeah, we have the all the date values of 21st November. If we see for 1002, 21st November 2011, 21st November 2011, and for this record is coming from EXST DTC into the DTC, and similarly these records are coming from EXEN DTC, and then now we have all the dates in a common variable named DTC. So to pick the earliest or latest, we can use DTC when deriving TRT SDT and TRT EDT. So now let us see how TRT SDT and EDT are being derived using the logic. So we are using this pooled dataset which contains EXST DTC and EXEN DTC in the same named variable called DTC, and then passing it into the filter function to filter the required rows. So here we are filtering the rows where EXCAT is equal to treatment period, and then also filtering only the rows where the exposure dose is greater than 0 and date is not missing, and then passing it further into the arrange function. So and within the arrange function we are sorting out the observation based on the values present in uSubjID and DTC variable, and then we are passing that further onto the group by function to group the records based on the values of uSubjID variable. So, and we are passing that group dataset to slice function and subsetting the first record within each group. So this is kind of subsetting first record within each uSubjID using first.uSubjID. So first sort the record such that the first record contains within the subject contains the earliest date. So we are achieving that using arrange function, and then indicate that the records are to be grouped, and then use the slice function so to subset the first record within each group. So slice function is used for subsetting the records based on the position of a record. So here when we say first, so it subsets the first record within each group, and then we are passing that subsetted data set into the mutate function to create new date variable TRT-SDT as using as date function applied on DTC variable. So we know that DTC is a character variable, and then we are converting it into numeric and storing it into TRT-SDT variable, and then keep only the required variables of uSubjID and TRT-SDT in this dataset. Let us take a quick look at TRT-SDT dataset. So here again, of the 3 subjects present in demographics dataset, only 2 subjects took the treatment, and we have the treatment start date obtained for those two subjects. And then for TRT EDT, what are we doing? So we are using that pooled exposure dataset, and then passing it on to the filter function. Here again we are sorting the records based on use of JD and DTC variable in ascending manner. And then in order to subset the last record within each subject, we need to make use of this syntax, slice of n function. So what does n function return here is, so n function returns the number of records within each group. Let's take two cases where there is one subject with 3 records and the second subject with 4 records. So as we have grouped the data set based on the values in use of JD, for the first subject who had 3 records in input data set, the n function would return 3. And for the second subject who has 4 records, the n function would return the value of 4. So for the subject who only had 3 records, the third record is the last record, and for the subject who had 4 records, the fourth record is the last record. So we are making use of that logic to filter the third record for first subject and fourth record for second subject, which is equivalent to the last dot useObjId. So this is the logic. So group the records based on useObjId and subset the last record using slice function, and within the slice function we are specifying the position dynamically using n function. So and then passing the last record of each subject into the mutate function and creating TRT-EDT variable by converting the DTC into date using numeric date using asDate function, and then keeping the required variables of useObjId and TRT-EDT. And then similar to the exposure processing of pulling the start and end dates into a common variable by using a bind rows function. So this is kind of equivalent to your data step appending. So in the first instance, this gets translated as set SV and then again SV, and on the first SV we are using the data set option of rename and renaming SV STDTC to DTC. So this is kind of appending the same data set twice but using different date value into the date DTC variable on each instance. So we are combining them, and then for FSDT, so we are using that combined dataset, filtering only those rows where DTC is not missing, sorting the records based on use of JD and DTC in ascending manner, grouping the records as we are getting the deriving the first visit date. So we need to pick the earliest record or the first record within each sub-JD. That can be achieved using slice of 1. So this subsets the earliest or the first record within each subject. And then similar to the previous variables, we are using the DTC variable, converting it into numeric using asDate function, and then storing into FSDT, and then keeping the required variables. Similarly for LVSDT, so we are using the same logic, but we are subsetting the last record using slice, and within the slice function we are making use of n function, and then creating the variable, selecting the required variables. So as discussed in some of the previous videos on STTM, so using the tidyverse join function, so we cannot join more than 2 data sets at a time. So we can only at the max join 2 data sets. In order to facilitate joining more than 2 data sets at a time, we have uh, a function called reduce function from per package. So for that, what we need to do is we need to specify the list of data sets as the first argument to the reduce function, and then the function that we want to use. So in this case, we want to apply a left join function, and the third argument is the by variables here. So how does this work? So we want to join the datasets DM, RFICDT, RANDT, TRT, until all the way till LVSDT. So here we are creating a list of datasets and storing it in a variable named datasets. So we are passing that here. So how this gets evaluated is, so this DM dataset and RFICDT so gets joined in left join manner based on the values present in useObjId. So DM left join RFICDT to the resulting data set. So again, it left joins RANDT, and then once these three are combined, the resulting data set gets left joined using TRT-STT. So this is how we can make use of reduce function if we want to join multiple data sets within a single step. So otherwise you can write DM RFICDT left join and feed it further into another left join using RANDT, which we have already done in some of the previous videos on STTM. So, but if you want to apply left join or a joining function on multiple datasets, just keep in mind that we have a function called reduce from per package of uh, tidyverse, so which can be used to apply a particular function on multiple datasets. So at the end we have our ADSL dataset stored. So what we will do at the end is we will try to compare the output dataset generated from SAS and then the final dataset generated from R. So here is the output from SAS and on the right hand side I have the output from R. So we'll try to compare RFIC DTC first. So the formatting is a little different, but the date, let's check at the values only. 29 September 2011, 29 September 2011. So 14 November 2011, yes. So 14th September 2011, yeah, we have the RFIC DTC matching in both the cases. And then for RANDT, so we have it populated for subject 1002 and 1003 only. Yes, that is the case. 7th December, 7th December. So 4th October versus 4th October. So let's quickly move on to the last variable LVS DT and then see if it is coming properly or not. 29 September 2011, yes. 15th March 2012, yes. 1st November 2011, 1st November 2011. So we have quickly examined few variables manually whether they are matching or not. Yes, they seem to match. This is how we can make use of our tidyverse program to replicate the creation of key date variables which are commonly used in ADSL dataset. Thank you for watching and keep learning.